So, highlighted here, we are in day number 2 out of 3 days on algebraic fractions. Last class we talked about how to cancel when you have a single algebraic fraction. The moral of the story was factor first and then cancel. And we also talked about multiplying and dividing. Again, factor, cancel before you multiply or divide. So multiplication and division, surprisingly, are easier than addition and subtraction. So we're going to talk about addition and subtraction today, and we're also going to talk about it next class as well. So we're going to add and subtract algebraic fractions today and Friday. Monday is our last day of new material. Wednesday is the review day. Monday the 20th is our final exam. Questions before we take a look at the new stuff? 12:30 to 3. You should not have another exam at the same time. If you do, let me know. Okay, page 72. Let's come up here. Number 1. Sam. Okay, notice we didn't do a single addition problem last class. It was only multiplication and division. So what's good about these two fractions? They have the same denominator, which means it's easy to add them. What happens to that denominator? Does it become 6? Does it become 9? You just copy it, right? So a single denominator that's the same, you copy it. And then upstairs, you wouldn't ever normally write that, but I'm just going to be really explicit. You're doing 2 plus 5 on top. It happens that that's 7. But I just really want to be clear. When you have two fractions with the same denominator, you get to add the things that are on top. Yes? Okay. Number 2. Jenny, are you ready? Okay, we're just going to skip around and do a couple of these because the harder thing's coming up. But when they have the same denominator, addition and subtraction is easy. Just take a quick glance and convince yourself that all the problems in this big box have exactly the same denominators, right? So when we do 3x over 2 plus x over 2, what's the new denominator? 2. You just copy it. And then upstairs, again, you don't really need to write it, but I'm just going to be very explicit and say I'm just making one fraction, and we're going to add the two things that are upstairs. And if you can do more, then you should. 3x plus 3x plus x is really 4x. And normally that's the final answer, but if you can reduce, then you should. And this guy is reducible now because the operation is multiplication. So we can cancel 4 and the 2, and it just leaves 2 upstairs. Yeah, 2 over 1 is good. So the final answer is 2x. Questions on that one? Okay, what's nice about the fractions in B? Same denominator. We're subtracting. The new denominator is 5. You just copy it. And then upstairs, you also just copy. X, subtract 6. If we can go further, we should. Can you combine x and 6? No, so we're done. Questions on that one? Go ahead and do part C right now. I get 3x minus 1 over x plus 2. Any questions on that one? Yeah. I think it doesn't matter in this problem, but it will in some other ones, and it's a great suggestion. Put parentheses around the things that you bring together 2x minus 5 and the x plus 4. Now in this problem, it makes no difference because this plus sign in the middle says you don't have to worry about the parentheses. But in the next problem, without the parentheses, we're going to get it wrong. So let's start with this one. What's the new denominator? It's b. And then upstairs, we just copy the things that we had, y plus 1 and y minus 1. And what goes in between is a minus. And if you do this problem the way it sits, you will get the wrong answer. Because this subtraction symbol says subtract the entire thing, right? Yeah, just like that. So it's, oh, we could do other stuff with that too, I think. Try again. There we go. Fancy. I don't like to just show off, you know. Okay, so this is one thing right here, and it is being subtracted. And the fraction line tells you that the entire thing is being subtracted. But now I've lost it. And if I don't put parentheses, I'm going to get the wrong answer. The y minus 1, it was grouped separately by virtue of being on top of a fraction. Fraction line is like a separate grouping symbol. We lost the grouping symbol when we came over here, so we need to put it back. We need to put parentheses around it. So Sam is absolutely right. Safest thing to do is just put parentheses every time. And now we're going to get rid of those parentheses. Does the y plus 1 change because of the parentheses? No, it's just y plus 1. But that subtraction now distributes through these parentheses. What happens to the y? It becomes minus y. The negative 1 becomes a plus 1. Same denominator. Everybody okay with that minus sign distributing through? And now the y and the minus y cancel. 1 plus 1 is 2. Divide by b. Good? And if we didn't follow Sam's advice, and if we didn't put parentheses in here, what happens to the y's? So y minus y, that cancels. 1 minus 1, how much is that? 0. You get 0 divided by b, which is the wrong answer, right? What's that? Y minus negative 1. It should be 1 minus negative 1. But if we don't put parentheses in there, then this subtraction now only applies to the y. And in your head, you're putting it there, which is the right thing to do. But without parentheses, we get the wrong answer. Okay, so we'll put them in there. Let's do part F. Can you guys try that one and check with your neighbors? Again, bring in the parentheses, just like Sam suggests. All right, so upstairs I got a negative 2x plus 2. Is that right? Questions on that one? And again, if you don't put those parentheses in there, you will end up with a minus 5 here, whereas really it turns into a plus 5. You'll just get the wrong answer. So bring those parentheses in every time. If we can go further, we should. Are we allowed to cancel, for example, the x's? No. So if you wanted to try to reduce this fraction, what would you have to do first? Is factor, right? Factor first is what we did all on Monday. So let's factor first. Upstairs, what number goes into both? 2. So let's pull the 2 outside. I'm just going to copy the bottom. Negative x plus 1 is good. Yeah, and this guy kind of looks familiar to me, actually. Upstairs, I have a negative x. Downstairs is a positive x. Upstairs, a plus 1. Downstairs, minus 1. This, if I were to rewrite it, would you guys agree, instead of writing negative x plus 1, that's the same as positive 1 minus x? I'm not changing the signs. I'm just rearranging it. And then look, 1 minus x and x minus 1, that's that funny thing where it's the same thing top and bottom, but backwards, right? And so I'm allowed to cancel them, but I have to pay. What do you pay? It's the minus 1. So then we do cancel these two things, 1 minus x minus 1 cancels, with the negative 1 left over either upstairs or downstairs or in the front, but only one of those places. And so that negative 1 multiplied by the 2 is negative 2. And that's our final answer. Questions on that? Okay, again, what made all of these additions and subtractions easy? Same denominator. So now we're about to relax that. We're going to make them harder. We're going to handle ones that have different denominators. So let's go on to the next page. And we're going to try this problem up here at the top, but can you make a little change? That 5, change it to a 9. To the 5 at the very top. Let's make that a 9 over 28. Everybody has the change? 9 over 28. Okay, so this problem does not belong in Math 106. This is a Math 090 problem. This is a basic arithmetic problem. But I want us to remember how to do the basic arithmetic problems, and then the process we follow here, we will then be able to apply to the 106 level problems with all the x's floating around. So what's the first thing to do when you don't have the same denominator? Is to make them the same. You got to find a common denominator. Now, there are a lot of different common denominators. If you do, you don't need to write this, but if you do 20 times 28, you get 560. That is a perfectly good common denominator. It will work. Both 20 and 28 go into that number. That is a common denominator. But usually we don't just seek any old common denominator. Which one do we want? The lowest one, the smallest common denominator, the least common denominator. And there's a number that's smaller than 560 that both 20 and 28 go into. It's not clear to me what that number is. I can't, sometimes I can just look at the two numbers and know, but I can't for 28 and 20. I don't know those numbers well enough to just know right away what the smallest number is that both of them go into. So here's a process we're going to follow. Step 1, factor all denominators completely. So let's factor 28. There are a couple of ways to factor 28. You could do 4 times 7 or 2 times 14. Which one do you pick? Makes no difference to me. We'll do 4 times 7. Doesn't matter. But this isn't done because you can factor further. What is 4 equal to? 4 is equal to 2 times 2. Can you factor 7 any further? Oh. Thank you. Can you factor 7 any further? No. So 2 times 2 times 7. That is factored completely. What kind of numbers are all those? Primes. Good. The primes are all the numbers that can't factor anymore. Those are those pink numbers there on the back wall. That bottom row is the list of the first 20 prime numbers. Okay, we'll play the same game over here with 20. So we factor it. There are different ways to start, but there's only one way to end. So how could you factor 20? It's 5 times 4. You could also do 2 and 10. So I'll do 2 and 10 off here on the side just to convince you it doesn't matter how you start. We're going to end the same. Can you go any further with 5? No, we'll just bring this guy down. 4 is really 2 times 2. Up here, if we'd done it the other way, can we go further with 2? No, 2 is just 2, but 10 is really 5 and 2. And you guys see that the ending is the same. 5, 2, 2, 2, 5, 2. Same, just different order. Okay, so we factor completely, and that's it. Next thing we do is step 2. Put the factors for each denominator into a Venn diagram. I think the guy's first name was Charles Venn. Maybe it was Augustus. I get confused. Anyway, he's an old mathematician, and he came up with this idea of drawing circles to represent sets. And all we're going to do is put the denominators into this Venn diagram. Don't copy what I'm about to put. 2 times 2 times 7 can go over there. Don't copy this. 5 times 2 times 2 can go over here. Right? Those are the denominators. But what you want to do is take advantage of the overlap in this picture. Any factor that's the same in both should go in the middle. It shouldn't go on the outsides. So what do we see that's blue and also black? 2, and actually another 2. So in the middle, I'm going to put both of the 2's. And then in blue, I'm going to put the other blue factor. What is it? 7. I'll put a little dot there to remember its times. And in black, I'll put the other black factor, which is 5. There is the representation of those denominators. If you multiply the numbers in this circle, 7 times 2 times 2, 28, that's the first denominator. If you do the numbers in this circle, is 20, okay? Super. Here's the benefit of drawing out the Venn diagram this way. The benefit is that if you just multiply these numbers straight across, forget about the circles, but just go straight across, you will have found the lowest common denominator. 7 times 2 times 2 times 5, that is the lowest common denominator. So the LCD is, I'll put it in purple here, 7 times 2 times 2 times 5. I'll write down what it's equal to over here. It actually doesn't make any difference to me what it's equal to. I mean, it's 140, but I don't really care about that. 7 times 2 times 2 times 5. That's what I'm happy with. Is it better than the 560 I came up with first? It's a lot smaller. Okay. Next thing to do is rewrite the original fractions, but in factored form. So the original fraction up above, it was 9 over 28. But instead of 28, we're going to put 2 times 2 times 7. That was how we wrote 28. And then I'll write the other one over here. What was it? 20 divided by, thank you. Yeah, 3 divided by 5 times 2 times 2. Everybody see? Just copied from up above, but now it's factored. And now we're going to again take advantage of the Venn diagram idea, and we're going to build the right denominators. What's the right denominator? It's 140. That's the right denominator. How do you build it? Well, don't worry about the 140. Just know that you have to get all the purple factors. 7, 2, 2, and 5. What is this blue fraction missing downstairs? Is the 5. Yeah? It's got the 7, it's got the 2, it's got the other 2. It's missing a 5. So right over here, I'm going to put a 5 in the bottom. But I can't go around multiplying a denominator by 5 without right away doing what? Multiplying the numerator by 5. And that purple fraction is called, what was our funny name? It's a foo-foo. That is a fancy form of 1, and I'm allowed to multiply by 1. Everybody understand why 5 was the right thing to put downstairs? Yes. So what we're trying to do is build this LCD, which is in purple here. 7 times 2 times 2 times 5. Looking at the denominator I had, I've already got 2, 2, and 7 taken care of. 2, 2, and 7. 5 is the one that's missing. The second one first. This one? Yeah, so this is what we need to do in the second one. It's a different thing we're missing. So Jenny says we're missing the 7 down here. Do you guys agree? 5, 2, and 2. 5, 2, and 2. We're missing a 7. I'll put it in purple. I need to multiply down there by 7. It's a completely separate thing. Maybe I'll put like a big line in the middle just to really separate them. What goes in the top here? 7. So far, so good? Okay. So we've got our new fractions. So let's put in the new fractions. So the blue one, I'm just going to copy the whole denominator, 2 times 7 times 5. Upstairs is just 9 times 5, which is 45. In black, 5 times 2 times 2 times 7. What's upstairs? 21. And these two were supposed to be added together. Okay, and what's the good thing about these two fractions now? It is addition. We can just add them on the top because what's true about the denominators? They're the same. They're both 140. Again, I don't need to write 140. I just need them to be the same. So we can just add them up on top. So I'm going to write it 45 plus 21 divided by the denominators. So that looks like 66 divided by 2 times 2 times 7 times 5. Okay, is this reduced? It's not. There's a number that goes into both top and bottom. And again, I don't care about the 140. I'm quite happy leaving it as 2, 2, 7, and 5. But I should factor the 66. So 66 is really what times what? Yeah, it's 2 times 3. That gets me the 6. And then times 11. And now because it's multiplication, because it's factored, we can cancel. So one of those 2's goes away. That's a foo-foo. So our final answer is, and now we'll actually make it one number. So 33 divided by 70. Okay, so I don't do this to discourage you, but just to show you what the calculator can do. So what did we start with? 9 divided by, what was the first one? 28 plus 3 divided by 20. Now the calculator is going to give me a messy decimal. Now what should I do to see if that's the right answer? What should I type in? Yeah, if I type in 33 over 70, then I'm hoping it's the same messy decimal. There is a way to get the calculator to convert that to a decimal. We go inside of math. And that very first one says convert to, that's the arrow, send it to a fraction. And so if I just hit enter twice, it gives me the 33 over 70. What the calculator can't do is any of the other problems we're going to do today. The calculator cannot tell me what 1 over 3x. So the calculator can't do this. It can't handle anything with x and the y. It can't do algebra. It's just, it's good. It's really good at arithmetic, but it really can't do much else. Okay, so let's try this one here. 1 over 3x plus 3 over 5y. So we're going to follow that same very detailed process several times today, so you'll get the hang of it. Like, don't worry about, oh my God, I have to memorize these 7 or 8 steps. It'll become easier with practice. But the first step is written over here. It says factor denominators completely. 3 times x, can you factor that? No, it's already 3 times x. It's factored. 5 times y is factored. So I'm just going to write 5y over here, and then in black, sorry, 5y over here, and then the 3x is the first one. And then we're going to write those two things in the circles, but anything they have in common goes in the middle. Do they have anything in common? No. There's a 3, completely separate from the 5. There's an x, completely separate from the y. So 3x goes over here, and 5y comes over here, and there's nothing in the overlap. So when I write the LCD, I just write 3 times x times 5 times y. And sure, you can turn it into a 15. You might feel obligated to turn it into a 15. I don't want to turn it. Yeah, 15xy. I don't want to turn it into a 15. 15 is going to hide what I'm looking for in the next step, which is to find the missing pieces. So copying the original fractions, it was 1 over 3x, and it was, what was the other one? 3 over 5y. That's just copied. But now I need to build the lowest common denominator, which is there in purple. 3x times 5y. This fraction currently has a 3x. What's missing? 5y. So then over here, I'm going to multiply by a 5y right down there. But I can't do that without putting what upstairs? 5y. See if you can multiply the other thing by a different fraction, the right fraction. This fraction already has 5y. What is it missing? 3x. So we put that next to it downstairs. because that's what I want, and then upstairs because that's what I have to do. Questions on that? Okay, new fractions. We're just going to multiply straight across. 1 times 5y is just 5y divided by, and then I'm going to copy this. Again, you can change it to 15xy, but I'm quite happy to leave it factored. Okay, and then over here, upstairs, what do I get when I multiply? 9x. Can you see that? 3 times 3x. And I'm going to copy the bottom. And I think these two fractions were being added, right, at the beginning. So we'll just put a plus sign right there. Good question. Can we cancel the 5y and the 5y? This is multiplication, right? This is multiplication. You're good to go. You can cancel those and make it 1. The reason we don't want to do that is that 1 over 3x is what we started with, right? And we've done all this work to try to make it have the right denominator. Where are we going? So make it have the right denominator. Add things. One more. Undo, undo. Why is it bringing me back here? How did it? We did so many things ever since, like between then and now. All right, great question, Katrina. Okay, so we did that one, and Katrina asked over here. Okay, so can we cancel the 5y's? Absolutely, but that would be going backwards. We did all this work in order to make it so that these two fractions here have the same denominator. And do you see that this fraction and this fraction both have the same denominator, 3x times 5y. And so you're always going to have this opportunity to cancel. It's always going to be there. I can absolutely cancel that x with that x. I can cancel 9 and 3 and make 3 upstairs. But if you cancel, you're just going to go right back to where you started. So don't cancel. Avoid the temptation to cancel. Okay, again, what's nice about adding these two fractions? Same denominator, which means we get to just add right upstairs. So we're going to put up here 5y plus 9x divided by, and then we're copying the denominator. The order in the denominator doesn't matter, right? These two denominators are out of order. There it's 3x first, here it's 3x second. Doesn't matter. Just pick one and put it downstairs. Okay, how about now? Can I cancel 5 and 5? No, because what's the operation upstairs? It's addition. It cannot cancel there. Can you factor this guy? No. If we could, we should. Because if we could factor, then we could maybe cancel. But we can't do anything else. It's done. Now in the back of the book, it's not going to say exactly this. In the back of the book, the answer would have the bottom multiplied through. It would say 15xy. I'm happy with either answer. I go out of my way to leave it factored the whole time, because leaving it factored makes it really clear to me how to fill in what's missing. This was a 3x. What was missing? 5y. Leave it factored. Okay, so that one's done. Questions on that? Okay, let's try the next one. Okay, so we've got y over 2y minus 1 minus 2y over y plus 1. So first step is to factor all denominators completely. Can you factor anything out of there? Nope. Can we factor anything out of here? Nope. So they are factored. I'm just going to write them again. 2y minus 1 is one denominator. Y plus 1 is the other denominator. Now here's a spot which is kind of sticky for some folks when they first begin adding fractions like this. What do you see is the same, right? Because we want to put whatever is in common right there in the middle. So what's the same? Is a y. I agree the y is the same. But what we're looking for are factors. And because we couldn't factor it, how many things is this? It is one thing. It is one giant thing. I'll even put parentheses around it just to really highlight, because I couldn't factor anything, 2y minus 1 is one of my factors. And even though there's a y that's the same in both, you can't go in and try to pick out a y. Y is not a factor of both. Y is just part of both. Long story short is that the entire 2y minus 1 has to go there, and the entire y plus 1 has to go here. I'll go back a couple of pages to the numerical example we started with, just so we really see how we can split this thing up. When we took 28 and turned it into 2 times 2 times 7, we factored, right? This guy has 3 factors, 3 things multiplied together. This 2y minus 1 is a single factor. It doesn't have 3 things multiplied together or even 2 things multiplied together. Okay, sure, 2 times y is 2 things multiplied together, but we know that subtraction is a very bad thing. And so that subtraction needs to get absorbed, and the only way to absorb it is to just call the entire thing one factor. So again, you can't go inside. If you have addition and subtraction, you're just going to end up copying that entire thing as it is. Can't go inside and start picking out little pieces here and there, like the y from in here and the y from over here. We just copy them as they are, which means the lowest common denominator, we just multiply straight across, 2y minus 1 times y plus 1. Notice that I brought in those parentheses. I kind of introduced them artificially before, but we really need them. And this denominator is in factored form. It's one thing multiplied by one thing. Okay, so now we're copying the original fractions. What was the original? What was the first one? Y over 2y minus 1. What was the other one? Okay. So that's just copied. And now again, we're looking for what's missing. So currently this denominator already has 2y minus 1. It's got this entire thing. What is it missing? The y plus 1. So we're putting that right over here in purple. Y plus 1. Everybody see it? Upstairs, what do we put? Same thing. See if you can figure out what to multiply the other fraction by. Ask yourself what's missing in that denominator. Okay, what's missing here? 2y minus 1 is good, so we put it downstairs and also upstairs. Any questions on filling in the missing factor? Is it okay? All right, so let's write the new fractions with the right denominators. I'm going to leave the bottom factored. Do not feel obligated to FOIL that out. You really don't need to. Just leave it as it is. Notice that I did have to bring in what? Parentheses. Got to have parentheses. Same idea that Sam suggested before. So you need parentheses. You don't need to multiply it through. I'm going to write something that I don't need you to write. But if I write this upstairs, what's wrong with that? Y times y plus 1. We are going to combine terms, but what's wrong with it the way I've written it? Yeah, that y plus 1 was separated. It was one thing, and the fraction line tells you it is one thing, which means what's missing here is parentheses. So really, we got to have parentheses here. That's what we need. Let's go one step further on this one. I said you don't need to multiply on the bottom. In fact, I encourage you never to multiply on the bottom. But we are obligated to multiply on top. Top and bottom behave very differently. It shouldn't be clear why we're going to multiply on top until the next step. So just trust me on it for right now, but let's multiply. So distribute that y. What do we get? Y squared plus y. I'm saying yes, do that. Yeah. So here's the funny rule. Never distribute on the bottom. Always distribute on top. It'll make more sense once we finish this example. So once people are ready, we'll move on. We still have to deal with the second fraction. The blue one was only the first one. So the second fraction is this one right here. Should we distribute on the bottom? No. Should we distribute on top? Yes. So let's first write it. So downstairs, we're just going to copy it as it is. Upstairs, I'm going to write it down before I distribute. And parentheses are mandatory right there. Okay, so we said downstairs we're never distributing. We'll just copy that. But upstairs we have to. 2y on the outside comes in and hits both terms. What do we get first? 4y squared minus 2y. Good. And again, there's always this temptation, legal or illegal. Cancel those 2y minus 1s. That is legal. Yeah, it's perfectly legitimate to do that. It was multiplication, and we can cancel when we have two copies of the same thing for multiplication. But if you do that, all you've done is gone back to the original. We don't want that. You did hard work to get the right denominator. So even though you'll always have this opportunity, you never want to take it. Okay, so here's the next thing. Was this a subtraction or addition problem? This is a subtraction problem. So here's the subtraction. I'm going to write it down now. I'm going to copy my blue fraction, y squared plus y over the denominator. You know what? Just to save a little bit of time, I'm just going to start calling that LCD. That denominator right there is the LCD. How does it compare to this denominator? It's the same. So we'll just call it LCD. And then what was the next one? Then it was subtract the other fraction. This is now the black one. 4y squared minus 2y divided by what? The LCD. And what's the nice thing about subtracting these two fractions? Same denominator. They have the LCD. Even though we've done so much good work to this point, it's still possible to make a mistake and get it wrong. I will illustrate that mistake here. All I've done is copied. Just make it one fraction, right? Am I allowed to do that? It's the same denominator, right? So you just add or subtract upstairs Yeah. Might we want to throw some parentheses, or must we throw some parentheses? We must throw some parentheses. This and this. Parentheses. That was Sam's idea. So subtraction problems have this extra layer of difficulty because you can forget to put parentheses and it changes the answer. You've got to have them there. So let's combine and get our final answer to this problem. Okay, so we've got y squared plus y. Subtract what? 4y squared plus 2y, right? Subtract, subtract, divide by LCD, and now finally it's in a position for us to combine terms, combine like terms. How many y squareds? Negative 3y squared. How many y's? Plus 3y's. We are going to rewrite the LCD, but before we do, we're going to pause. Any questions so far? Melanie? I do. Yeah, so Melanie has discovered the bad news. But before we get to the bad news, remember I had said we got this funny rule in green, never distribute on the bottom, always distribute on top. Why do we do that? Because of, well, yeah, but even before we get to the foo-foo, the only reason that we were allowed to make this better was that it was all distributed out, right? Then we could see the like terms to combine. But if instead of distributing here, we had left it as a y times y plus 1, because that's what it was, and then subtract, I forget what this guy was. It was 2y minus 1, and then I think there was a 2y in the front. Like that green thing, you can't go any further unless it's distributed, and then you can combine terms. So that's why we distribute on the top, is because we know we're probably going to be able to combine like terms at the end. Okay, but then Melanie gives us the bad news, and the bad news is we do have to factor the top because maybe something is going to cancel on the bottom. Okay, what can you take out of both terms on the top? Take out a 3 and a y. And in fact, why don't we do just one extra thing? I don't like having a minus in front of my y squared, so how about I take a minus out as well? It's okay to take 3y outside, but for me, if I see a minus sign first, I like to take that outside too. You don't have to, no. So when we do take out negative 3y, what's left in this first term? Is a y, right? And change the sign, so the minus was outside. That plus 3y, taking out a minus 3y, it's a minus 1 in there. And now because we're ready with the final answer, I'm not going to write LCD, I'm going to write the actual denominator. Plus 1 is good. If this had been a y plus 1, what would we be obligated to do? Is cancel, right? Because then you'd have a y plus 1 on top and a copy of it on the bottom, and you'd cancel. That's why we have to do what Melanie suggested. Do we have to factor? Yeah, because there might be something that cancels. Sam? Mm-hmm. So if you took out a positive 3y, then this would still be plus, but this guy would now be minus. 1 minus y is actually not the opposite. If we wanted the opposite, it would have to be this. And you have two positive things here, not one positive and one negative. So they actually wouldn't be opposite. So 1 minus y and 1 plus y are not cancelable. Yes, exactly. It's got to be exactly the same, but all the signs should be flipped. Okay, so there were two other examples I wanted us to do together, but we're going to scratch those, and I want to make sure you guys have time to try these. They are difficult problems, so can you go 1 or 2 pages down the road and find this? It's hard to see it. It's all the way at the top. It says group activity. Everybody find it? Top left. What page? 77. So go to page 77. See if you can start. Follow this process. Raise the flag if I can help and work with each other.